Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Determine if two strings are close. So let us first read this question, then about constraint, then examples, and then finally the coding part for the same. So two strings are considered close if you can attain one from the other using following operation. Operation 1. Swap any two existing characters. For example, a, B, C, D, and here we are swapping B with E so that it can become A, E, C, D, B. Basically swapping any of the two existing characters, and then operation 2 is transform every occurrence of one existing character into another existing character and do the same with other character. And you can use operations on either string as many times as necessary. Given two string word 1, word 2, return true if word 1 and word 2 are close and false otherwise. Basically, as per the question which is given here, so this is somehow similar to yesterday's question only. Means the enneagram which we were doing yesterday, right? So like that only this is the question, and here we are required to do the operation of swapping or transforming the occurrence of the characters which is there. So on the similar lines of the enneagram, we can solve this question as well. So I hope you would have got the hint that how we are required to solve this question. But for more clarity, let us first check for the constraint. These are up to 10 raised to the power 5. So order of n or n log n could be the time complexity which we can use, but not more than that. And about examples, if we see here ABC which is there and BCA, all of them are like means basically both of the words which are there. Each character is similar to other. Only thing is that if we do some swapping, then it would be same word only, so that's why we are returning true here. Here we can clearly see that word 1 length is less than word 2 length, which is clearly depicted that we can't make them basically the same words, right? So that's why we are returning false here. Here if we see, if here we swap, and even if we change the words which are there, so according to basically the characters, if we change them to some other character, then the words will become similar. So on those similar line, we are required to solve this question. So now let us go ahead with the coding part for the same. So here, as I was saying that on the similar lines of Enneagram, first thing what we can do is, first thing we will be taking two vectors, one for the word 1 and one for the word 2. And here we will be taking 26 characters and initializing them with 0 so that we can keep the count of them into the shape. And another thing is we are required to take set so that we can check that how many unique characters which are there in this particular, so that we can easily interchange them if possible as per this operation too. Here we are required to interchange the characters, right? Means transform every occurrence of one existing character into another existing character. And because of that only we are taking set here. Now first thing is we will be checking the count of each character, and whatever character is there that we will be storing in our set. And same we will be doing for our other word which is given to us, and then we will be sorting them so that we can clearly see that after sorting means after sorting it will come in their lexicographical order, right? So there we will be checking if word 1 and word 2 both are equal, and set 1 and set 2 both are equal, means all the unique characters are also there, means similar unique characters are there, and the whatever count of those character is there, and the lexicographical ordering, everything is same, then we will be returning that as a true, else it will by default return as false. Because it can return false in the, if it returns false in this particular scenario, that simply means that we are not able to perform this operation too. And if it returns false in this scenario, that simply means that we can't perform this operation one, basically the swapping thing which is there. So this was for this particular question. Now comes the part about the time complexity and the space complexity. So here if we see, here we are, as per the length of these words we are doing, I mean we have that loop. So if we take the length of each word as order of n, and then at the end we are sorting them also, so that's why time complexity becomes order of log n. And about the space complexity, the first thing which here we are taking, that is a word, that is vector of 26 length, and the set s1 and s2 which can have at max n characters, so that's why the space complexity becomes order of n. And that also because all in that all the unique characters could be stored, and that also can reach at max till 26, and 26 is basically constant, right? So that's why space complexity here becomes order of 1. And why here I am not taking considering that 26 here, the thing is that the word length could go up to 10 raised to per 5 as it is mentioned here, right? So because of that only, here the traversal could easily take up to 10 raised to per 5, and here sorting will also take that only. So that's why time complexity is required to be written as n log n. But the space complexity, we know that in the set, because all the uniques are there, so at max 26 would be stored, and in this particular we are just storing the 26 characters only, because here we are directly storing that particular character and just incrementing its counts, and that's how we are storing into the same. So that's the reason. Now comes, yeah, now this was all for this particular question. If you like the solution, then do like the video, subscribe to my channel, and share this among your friends. So, this was all. Thank you.